Supersonic aircraft captured imaginations in the 20th century, and today, the race to push speed limits continues. An American startup, Hermeus, is developing a hypersonic airliner that could outpace even the legendary Lockheed SR-72. Based in Atlanta, Georgia, Hermeus aims to revolutionize travel, promising to cross the Atlantic in just 90 minutes. Let's explore how their quarter-horse aircraft, powered by cutting-edge technology, is set to redefine aviation, and what makes this project a potential game-changer. Founded in 2018 by former SpaceX and Blue Origin engineers, led by CEO AJ Piplica, Hermeus is part of the New Space movement, commercial aerospace ventures focused on innovation. While many focus on space access, Hermeus targets hypersonic flight, aiming to make ultra-fast travel accessible. Their flagship project, the Quarter Horse, is named after the swift American quarter horse, reflecting its goal of covering vast distances quickly. In 2019, Hermeus announced the Quarter Horse, a hypersonic unmanned aircraft. By August 2020, they secured a $1.5 million U.S. Air Force contract to explore its potential for the presidential fleet, possibly supporting Air Force One. In 2021, NASA partnered with Hermeus to develop a Mach 5 aircraft with a 600-mile range, building on NASA's hypersonic legacy, including the X-15, Mach 6.7 in 1967, and X-43, Mach 9.6 in 2003. This collaboration leverages NASA's expertise to assess the Quarter Horse's technological maturity, ensuring it meets ambitious goals. The Quarter Horse's core innovation is its turbine-based combined cycle (TBCC) engine, named Chimera. Unlike traditional jet engines, the Chimera integrates a turbojet and a ramjet, enabling seamless transitions from takeoff to hypersonic speeds. The turbojet operates from standstill to Mach 3.3, while the ramjet kicks in from Mach 2.8 to beyond Mach 5. This dual-mode system eliminates the need for a rocket booster, making the aircraft reusable and adaptable to existing airports. The Chimera's development began with the GE J8521 jet engine, used in Northrop F-5 jets for its reliability. Hermeus acquired 6 J85S to test their TBCC concept. In 2019-2020, they conducted initial tests using a 290-pound thrust TJ100 turbojet from PBS, a Czech high-speed turbine manufacturer. These tests incorporated a custom pre-cooler and ramjet. The pre-cooler lowers incoming air temperature, allowing the turbojet to perform at higher speeds before transitioning to the ramjet, which compresses air at high pressure for thrust. Testing took place at Hermeus's Site 27, a converted shipping container near DeKalb Peachtree Airport's decommissioned Runway 27. In just 33 days, engineers prepared the facility, completing 50 test runs in 4 weeks. They accelerated the turbojet to Mach 3.2, then switched to ramjet mode, reaching Mach 4.5. A key challenge was managing the transition between modes and insulating the turbojet from the ramjet's 1,800 degrees Fahrenheit heat. Hermeus developed a pressure burner, ram burner, nozzles, and a bypass system to achieve this. In summer 2022, Hermeus demonstrated the Chimera's afterburner at Site 27, proving it could operate at full throttle on the ground. To simulate high-altitude conditions, they moved to the University of Notre Dame's Turbo Machinery Laboratory, which replicates flight-like pressures and temperatures. In November 2022, after 21 months and $18 million, Hermeus showcased the Chimera's transition from turbojet to ramjet, a critical milestone in hypersonic propulsion. Hermeus's approach extends beyond propulsion. About 15% of the Chimera engine was 3D printed, accelerating production. Using Velo 3D's Sapphire and Sapphire XEC printers, Hermeus crafted parts from Inconel 718 superalloy, ideal for high-stress environments. This additive manufacturing, common in hypersonic and space industries, allows for complex, high-performance components without compromising quality. The technology also streamlines production for the entire Quarter Horse, reducing costs and timelines. The Quarter Horse is designed for unmanned operation, with a flight deck supporting off-grid missions in austere environments. It includes space for a payload operator, mission analysts, and observers. A high-performance computing center, HPCC, features dual-redundant, cloud-based computing and power systems, meeting Department of Defense (DoD) requirements. Built to DoD secure room standards, it supports video conferencing and operations, all housed in an unmarked intermodal container for global deployment. While exact dimensions remain undisclosed, 2021 reports suggest the quarter horse is about 40 feet long with a 10-foot wingspan. It's designed to reach Mach 5, covering 4,600 miles, making it ideal for transatlantic flights. Hermeus plans its first flight test in 2024, a medium cargo version in 2025, and a 20-seat commercial passenger version by 2029. Developing a hypersonic airliner is no small feat. The Chimera's ability to switch from turbojet to ramjet at Mach 3 is a technical triumph, addressing the heat and pressure challenges of hypersonic flight. At 80,000 feet, the aircraft faces extreme temperatures which the pre-cooler mitigates by cooling incoming air. The ramjet's high-pressure combustion delivers thrust at speeds where traditional jets falter, making the quarter horse a viable hypersonic platform. Hermeus's rapid progress, achieving key milestones in under 2 years, silenced skeptics. Their use of existing engines, like the J-85, combined with innovative components demonstrates practical engineering. The 3D printed parts and adaptable design ensure the quarter horse can integrate with current infrastructure, unlike previous hypersonic vehicles requiring specialized facilities. The quarter horse could revolutionize travel, much like cars transform transportation. A 90-minute transatlantic flight would shrink global distances, boosting commerce, tourism, and connectivity. For the military, it offers a fast, reusable platform for critical missions, potentially serving Air Force One. NASA's involvement underscores its potential to advance hypersonic research, building on decades of experimentation. Compared to the Lockheed SR-72, a hypersonic reconnaissance drone, the quarter horse prioritizes commercial and passenger applications. Its TVCC engine, unlike the SR-72's scramjet, offers versatility for varied missions. Hermeus's focus on cost efficiency and existing infrastructure sets it apart, potentially making hypersonic travel accessible sooner. Hermeus's timeline is ambitious: a first flight in 2024, cargo version in 2025, and passenger service by 2029. Success hinges on overcoming technical hurdles like scaling the Chimera engine and ensuring safety at Mach 5. The startup's partnerships with the U.S. Air Force and NASA provide critical support, but the commercial landscape is competitive, with rivals like Boom Supersonic also pursuing high-speed travel. If Hermeus succeeds, it could redefine aviation, making hypersonic travel a reality. The quarter horse's blend of speed, range, and adaptability positions it as a transformative force, promising a future where global travel is faster and more efficient. The Hermeus quarter horse represents a bold leap toward hypersonic travel, blending innovation with practicality. As it prepares for its first flight, the world watches a potential revolution in aviation. Thank you for joining us to explore this groundbreaking project. Stay tuned for more updates on the technologies shaping our future.